Next up on our discussion on impulse and momentum, we have conservation of momentum. Just like energy, momentum is a conserved quantity. It is subject to the principle of conservation of momentum. You'll recall our discussion on momentum, we mentioned impulse. Impulse is change in momentum. F net is equal to dp over dt. If there is the presence of an external force, the momentum of the object will change. In the absence of a net external force, the momentum of an object is constant. Initial momentum of the system or object is just equal to the final momentum of the object or system. But in the presence of an external force, if the net external force is not zero, then that external force will produce an impulse, will produce a change in the momentum of the system. This impulse produced by the external force must be taken into account. So our conservation of momentum equation must take into consideration that impulse, initial momentum Pi plus the impulse produced by the net external force is equal to the final momentum. So Pi is equal to integral of F net dt from initial time to final time is equal to Pf, final momentum. So basically, total initial momentum of the system is equal to final total momentum of the system. So just like in conservation of energy, we have two cases to consider. No net external force. Initial momentum Pi is just equal to final momentum Pf. But in the presence of a net external force, the impulse produced by that net external force must be considered. So P, initial momentum Pi plus impulse due to the net external force is equal to final momentum Pf. And again, momentum is a vector quantity, so when doing analysis using momentum, be sure to use your component method. That's it for now. In the next video, we'll look at some examples on the application of conservation of momentum. So once again, that's it for now. Thank you for watching.